It's steam time. It's steam time. It's steam time. Hey, hey, hey. It's steam time. It's steam time. It's steam time. Hey, hey, hey. Steam scholars, it's been pretty cold lately. I don't know about you, but I think it's time to heat things up. Did someone say heat? Well, hello, Sunny. It's so good to see you. I think it's time to bring the summer temperatures to winter. What do you think, Sunny?
Yeah, let's bring on the heat.
To begin, we will start by going over the design process, followed by saying what STEAM stands for. The design process is something we as engineers and scientists will use every time we create or do an experiment. Feel free to say each step with me. With any project, we are going to A. Ask, what is the problem or what am I trying to create or solve? B. Brainstorm. How can I solve or make what I'm trying to create? C. Collect. Collect information, data, or use prior knowledge to help create your project. D. Develop. Start creating your project. E. Evaluate. What works? What doesn't work? And what can I do to make it better? F. Fine-tune. I will try again until my design is where I want it to be. STEAM stands for science, technology, engineering, art, and math. Great job! It is student question box time, where we want to hear from you. Today's questions read, why are some things hot and some things cold? How does my warm hand become cold when I touch something cold? And what makes things frozen? Why do things melt? We will explore these questions and more all throughout this unit. So let's explore. Heat is energy that flows from hot objects to cooler objects. Energy is the ability to do work. This unit, we will become scientists and use technology. We will become an engineer, make art, and use our math skills, which is every letter in the word STEAM. This is going to be awesome. Let's explore. Now that we know that heat is energy, which is the ability to do work that flows from hot objects to cooler objects, let's look deeper into the science of heat. Scientists refer to the energy an object has because of the movement or vibrations of its molecules as thermal energy. The movement of the molecules causes objects to be hot or cold. Everything on Earth is made up of molecules. Molecules are in you, even you in the back, and me. Molecules are very, 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 very small and always moving. The more they get excited, the more they move. The faster they move, the more energy it has, which makes for a hotter object. The slower the molecules move, the less energy it has, and the colder the object. What objects in your classroom can you find that you think have slow or fast-moving molecules, and why? Take some time to discuss with your class now. Super! I like the way you think. Here's a deeper look. Close your eyes and imagine yourself sitting in a classroom, reading a book. You may be using little to no energy, which is the ability to do work. Your molecules are slow moving, which means they are using less energy, which may make you cold. Now, imagine yourself outside playing basketball. You're moving, which means you are using energy, the ability to do work. This causes your molecules to move fast, which produces more energy and causes you to feel warm and your temperature to rise. To gain more understanding, take a look at the animations on the screen, showing the pace of the molecules of a person reading a book and people playing basketball. Look how fast the molecules of the basketball players are moving compared to the person reading the book. The person playing basketball will feel a lot warmer as their temperature rises. Temperature is how hot or cold something is. It measures the energy of an object. We measure temperature by degrees. Degrees are the numbers on a thermometer measured by Celsius or Fahrenheit. Why do you think fast-moving molecules can cause something to be hot? Amazing idea, STEAM scholars! Now that you know more about heat, thermal energy, and what causes things to be hot or cold, we will go over the 3 ways heat travels. Heat travels by conduction, convection, and radiation. Conduction is the heat you feel when you touch a hot object. Convection is heat transfer, and transfer means to move from one place to another by fluids such as air, gas, or liquid. An example of this would be cooling yourself off with a fan or the steam from a hot bowl of noodles. With convection, the air moves in a circular motion. Cool air sinks and warm air rises. And lastly, radiation. Radiation is a transfer of thermal energy, the energy an object has because of the movement or vibrations of its molecules, through electromagnetic waves. Radiation doesn't rely on the touch between the heat source and the heated object. It gives out heat like when you feel the warmth from a campfire. Need more time to process? Don't worry, we will take everything one step at a time. Today, we will focus on the conduction by doing an experiment that shows how heat transfers from one object that is hot to another object that is cooler and makes the cooler object hot. For this challenge, we are going to conduct our own experiment to test what conductors melt ice the quickest with an experiment I like to call conducting the conductors. Conductor in science means to carry a form of energy, like heat by conduction. Remember, conduction is the heat you feel when you touch a hot object. For this project, you will need ice, a thermometer, a timer, an aluminum pan, a paper plate, a styrofoam bowl or a black plastic container, a paper towel, a plastic lid, or a cup. You're conducting the conductor's data sheet, a pencil, and your design process notebook. Step 1. In your groups, each of you will choose a different object to test and lay it out on your desk. Next, take out your conducting the conductor's data sheet and pencil. Read the directions on the data sheet. Now you'll measure the classroom in degrees using the thermometer. My temperature reads 70.9 degrees Fahrenheit. Next, complete questions 1 through 4 on the data sheet. Number 1 says, measure the classroom temperature in degrees using the thermometer. So mine was 70.9 degrees. Number 2 says, touch each conductor with your hand to feel the temperature. Is the item hot or cold? Write the letter H down for hot and the letter C down for cold. This feels kind of cold. My paper towel feels pretty warm, but hot, cold. My plastic lid is kind of cold. Paper plate is hot. And My bowl is kind of cold. Number 3 says measure the temperature of each conductor in degrees and write the thermometer readings below. So you'll point it. So this was 70.9. This is 73.9. $71.6, $72.7, $74.5, and this one is 72.1. Number 4 says, which conductor do you think will melt the ice the quickest? You'll number it 1 through 4. 1 being the slowest and 4 melting the quickest. So I think my aluminum pan, I think it'll be a 3. And my plastic lid, I'm going to say a 1. My paper plate, a 2. My plastic cup, I'm going to say a 4. And my paper towel, a 3. Now you're going to place 1 ice cube on each of your conductors. So each of you guys have your own conductors and you place an ice cube on them. Now check your conductors every 5 minutes using the timer. Use the worksheet to help you track your data. So on the back page, there's a data sheet where you can draw what the ice looks like for each conductor and at the specific times. Answer questions numbers 6 through 8 on the back of your data sheet. And go over any results as a class. What did you notice about certain conductors? Did everyone have the same results? Do you think sitting by a window, a vent, or a heater would make a difference on how fast your ice melts? That is all for today's STEAM Scholars. Today, we explored heat, or what scientists like to call thermal energy. Not only were you a scientist today, but you used technology to help you with your challenge experiment. Technology is any useful tool that makes life easier. Next week, we will explore convection, and we will get to see with our own eyes what it looks like when molecules move fast and slow. For now, enjoy learning about conduction. Never stop asking questions, and remember to write down any new questions or thoughts you have in your design process notebooks. Until next time, my STEAM Scholars, be great and keep exploring. Bye-bye.